morning, students. Today we are going to deal with an important aspect in the field of pharmacology, which is receptor theories. This video lecture is basically meant for students of pharmaceutical science, and it is part of the curriculum of MSc Pharmaceutical Chemistry as well as B.Pharm and M.Pharm. Now coming to the topic. Pharmacology is the branch of medicine which deals with the uses, the effects as well as the mode of action of drugs. And hence an understanding of the mechanism of drug action is essential for the same. As you know, every drug is a chemical, and the drug will have some kind of interaction with the target site in our body. And this interaction can be via enzymes, ion channels, transporters or receptors, which we are concerned about today. And in today's lecture we are going to learn about receptors as well as the theories associated with the same. Now, what is a receptor? A receptor is a macromolecule or a binding site which is located on the surface or inside of a cell. And this macromolecule will serve to recognize the drug, which is a chemical, and will further initiate a response, a biological response to it. The general mechanism for drug action is D plus R. D is drug, R is the receptor, and this will form DR, which is the drug receptor complex. So the drug and the receptor will form a drug receptor complex, and this drug receptor complex will give you the biological response. Now, every theory that we are going to discuss today will give us an idea about how a drug will interact with the receptor to give a biological response. Now, the major theories are one, occupancy theory, 2, rate theory, 3, induced fit theory, macromolecular perturbation theory, and finally activation aggregation theory. Now, the first theory that we are going to discuss today is occupancy theory. Occupancy theory is a classical theory developed by scientists Gadan and Clark in the year 1920, and was further extended by scientists like Child, Stephenson, and Aryans. According to the theory, the response of a drug is directly proportional to the amount of the drug receptor complex that is formed. So, the response of a drug will be directly proportional to the concentration of the drug receptor formed. So, the response will be independent of the concentration of the drug that we administer. So that is an important point. The response will be directly proportional to the drug receptor complex, but it will be independent of the drug that we administer, the amount of the drug that we administer. Another important point is different drugs will have different response towards a particular receptor. Some can act as agonist, some can act as antagonist, or even partially agonist. So the crux of the theory is very simple. The response of a drug is directly proportional to the drug receptor complex that is formed. Now we are going to the next theory, which is called the rate theory. The rate theory was put forward by scientists Peyton and Run in the year 1965. Peyton and Run in 1965. They proposed that the biological response of a drug is directly proportional to the rate of formation of the drug receptor complex. So, response proportional to the rate of formation of drug receptor complex. Here, rate means, or rate is defined as the number of encounters with the receptor in unit time. So, number of encounters with the receptor in unit time. So, essentially, it is the rate of association or dissociation of the drug with the receptor. It is the rate of association or dissociation of the drug with the receptor that will define the response, and not the number of receptors occupied. So, rate of association or dissociation. And not number of receptors occupied. So to summarize this theory, it was put forward by Peyton and Rahn in 1965. Here response is directly proportional to the rate of formation of drug receptor complex. Here the rate means the number of encounters in unit time, and finally it is the rate of association or dissociation that will define the response, and not the number of receptors occupied. Now the next theory that we are discussing is called the induced fit theory. The induced fit theory was proposed by Koshlet, and this theory is related with the conformation of receptors. When a drug approaches the target receptor, the receptor may not be in the right orientation, the right conformation to bind with the drug. And the drug will induce a conformational change, giving a proper orientation to bind with the receptor, which will in turn give you the biological response. The important point is that the drug will induce a conformational change on the receptor. This can be easily understood from this figure. As you can see, the receptor was not in a position to bind with the drug because it didn't have the correct right conformation for the receptor. So the drug induced, as the drug approached the receptor, it induced a conformational change on the receptor, and this formed the drug receptor complex, which will give you the biological response. So the drug induced a conformational change on the receptor so that it can fit on the receptor. So this is the induced fit theory. So there are two parts to it. If the drug is an agonist, you will get a biological response. If it is an antagonist, there will be no response. So, an agonist as well as an antagonist can induce a conformational change on the receptor. If an agonist binds with the receptor, you will get a biological response. If an antagonist binds with the receptor, you will get no response. So this is the induced fit theory. The drug inducing a conformational change on the receptor so that the drug can fit on the receptor. So this is induced fit theory. Now the next theory is called macromolecular perturbation theory. Macromolecular perturbation theory was put forward by Below, and it is very much similar to the previously discussed induced fit theory. In induced fit theory, the drug interacts with the receptor and induces a conformational change. Here, the interaction of the drug with the receptor brings about a perturbation. And there are two kinds of perturbations. One is specific conformation perturbation, SCP, and non-specific conformation perturbation, NSCP. Now what is SCP and NSCP? The perturbations which can bring about a biological response. Such perturbations are called specific conformation perturbation. That is, the drug interacts with the receptor which produces perturbations and will finally give a biological response. Such perturbations are called specific conformation perturbation. Now, non-specific conformation perturbation is when a drug interacts with the receptor, perturbations occur, but you will not get any response. Such perturbations are called NSCP. So, for agonist, an SCP will happen and a response will be there. While for an antagonist, the perturbation is NSCP and you will get no response. So, for partial agonist, that is, those drugs giving partial response, they will have both the SCP as well as NSCP. So, SCP and NSCP will give you a partial response. So, macromolecular perturbation theory is concerned with perturbations, SCP and NSCP, specific conformation perturbation leading to a response, and non-specific conformation perturbation leading to non-response. And for agonist, specific conformation perturbation will happen. For antagonist, NSCP will happen, that is non-specific conformation perturbation. And for partial agonist, both these characteristics will be there, which will give you a partial response. So this is macromolecular perturbation theory. And finally, we will look into activation aggregation theory. Activation aggregation theory was put forward by Jaguar and Carlin, and according to this theory, in the absence of a drug, there exist two forms. First form is the active form and second form is the inactive form. And there, in the absence of a drug, there exists the dynamic equilibrium between these two states. That is, inactive form T0 in equilibrium with active form R0. So in the absence of a drug, there will be two forms, inactive form and the active form, and in the absence of a drug, it is also in a dynamic equilibrium. In the presence of a drug, the equilibrium will shift to either one of the sides. That is, if the drug binds to the active form, the equilibrium will shift towards the active form and you will get a response. If the drug binds to the inactive form, the equilibrium will shift towards this side and you will get no response. That is, for an agonist, the agonist will bind to the active form and will give you a response, while the antagonist will bind to the inactive form and shift the equilibrium towards this side and will give no response. So finally for partial agonist, that is drugs which have partial response, they will bind to both inactive form as well as the active form. So to summarize, in the absence of the drug, there are two forms and there is a dynamic equilibrium. In the presence of the drug, the equilibrium will shift. For an agonist, the agonist drug will bind to the active form and will give the response, while for an antagonist, it will bind to the inactive form and will give no response. For partial agonist, the partial agonist can bind to both inactive form as well as the active form, thereby giving a partial response. So this is the activation aggregation theory. Now let's summarize all the 5 theories. So for occupancy theory, the first theory, the drug and the receptor will form a drug-receptor complex and the response is proportional to the amount of drug receptor formed or the concentration of the drug receptor that is formed. So response proportional to concentration of the drug receptor complex. In rate theory, the rate of formation of drug receptor complex was proportional to the response. So that in other words, the rate of association or the rate of dissociation will define the response of the drug. In the third theory, induced fit theory, the drug induces a conformational change. Induces a conformational change. And this conformational change on the receptor will give you the drug's response. In the fourth theory, the macromolecular perturbation theory, which was similar to the induced fit theory, there were two kinds of perturbations, NSCP and SCP. Where NSCP will give you no response, that is, the perturbations of antagonist will be NSCP and you will get no response. For an agonist, SCP will happen and you will get the biological response. And finally, for inactivation aggregation theory, there are, in the absence of the drug, there are two forms present, and it is in a dynamic equilibrium. So when the drug binds to the active form, you will get a response, and when the drug binds to the inactive form, you will get no response. So T0 and R0. If the drug binds to T0, you will get no response. If the drug binds to the R0, you will get response. Now these are the 5 major theories, 5 major receptor theories explaining the interaction of a drug with a receptor.